So hi, everyone. Welcome to the Digital Benefits Network and our AI-powered Rules as Code research briefing and discussion. We really appreciate you taking the time to join us and discuss this important topic during these changing times. I'm going to be covering some housekeeping items today and then hand it over to Ariel. For those of you I haven't met, my name is Elizabeth Bynum-Sorrell, and I'm Senior Manager for Research and Engagement with the Digital Benefits Network. As you may have noticed, we are recording today's presentation for sharing on the Digital Government Hub. We will not be publishing the question and discussion portions of today's session, but we will be using the transcript for note-taking purposes. We have some reminders on the screen here and kindly ask that you maintain a respectful, open, and participatory attitude throughout this meeting. The Digital Benefits Network is dedicated to providing a harassment-free experience for everyone. We do not tolerate harassment of participants in any form. If you have any questions or concerns, please email us at digitalbenefits@georgetown.edu. And moving on to the next slide, here is our agenda for today. So we'll be kicking off with a brief introduction of the Digital Benefits Network and the Massive Data Institute. Next, we'll discuss key findings from the recent research publication on AI-powered rules as code. And then our final segment will be an open discussion. We have some questions to kick things off, but please be prepared to ask your own questions. And thank you once again for your participation today. With that, I'd like to hand it over to Ariel.
Thank you to that wonderful welcome, Liz. And great to see everybody who's joining us today. Thanks for taking some time in your afternoon to spend with us. I wanted to introduce you first to the Digital Benefits Network, if you're not familiar with us. We are a program at the Beeck Center for Social Impact and Innovation, which is part of Georgetown University. And we work to support government in delivering public benefits and services and technology that are accessible, effective, and equitable in order to ultimately increase economic opportunity. We work across key benefits programs, including food and nutrition, health, cash assistance, childcare, and unemployment insurance, in order to identify shared challenges and opportunities and amplify strategies to enable equitable and effective implementation. Today, we're also joined by our colleagues at the Massive Data Institute, which are part of Georgetown's McCourt School of Public Policy, where MDI is an interdisciplinary research institute that connects experts across computer science, data science, public health, public policy, and social science to tackle societal scale issues and impact public policy in ways that improves people's lives through responsible and evidence-based research. So together for the past several years, we've been exploring a concept known as rules as code. And thankfully, our international colleagues at the Organization for Economic Cooperation and Development, or OECD, has a definition for us for rules as code that we like to use in our own work. And OECD defines rules as code as an official version of the rules, e.g. the laws and regulations, in a machine consumable form, which allows rules to be understood and actioned by computer systems in a consistent way. For those of us that work in benefit systems, we currently know that every system that's used for checking eligibility, applying and enrolling and managing benefits has rules currently encoded in it. However, a lot of that current implementation requires going to many sources, like a tangled mess of rules that may conflict with each other across multiple programs. They vary by state, and they really require an immense amount of interpretation of the goals in a policy as it transforms into code. So we've been excited about a different way, and under a rules as code approach to benefits eligibility policy, where the policy, the laws or regulations would be translated into both plain language logic flows, also sometimes referred to as pseudocode, and computer consumable code developed in a standardized syntax. These code systems could then be implemented in digital systems, including benefits applications, eligibility screeners, policy analysis tools, and more. And under this structure, it would allow any stakeholder to review the legislation or regulation, plain language logic, and code side by side and know that all are official and ready for implementation. We believe through this approach, we could really improve the transparency, efficiency, and open new possibilities in the benefits, service delivery, and policymaking if code for the rules is standardized and open. Looking at our rules as code work, we branch across our community of practice, research, and initiatives that we run. You can find our research on our website, and if you're not already a member, we'd love to welcome you to our rules as code community of practice, if that's of interest to you. We originally started publishing on rules as code in 2022 and hosted our first demo day that year. We've published multiple reports since then looking at different aspects of policy and rules communication and the future of it with code. And last year we hosted a policy to code prototyping challenge, which I'll tell you more about in a minute. And this year we're really focused on the report that we're going to share more about today in AI-powered rules as code. And then we're also very eager to be conducting research with states on your eligibility and enrollment systems and the processes on how you take policy into code. And we're also working with other partners on program design for prototyping and open syntax and code library. So we're eager to hear from you on those activities and what might be most useful in the year ahead. But to get on with the research that we're really proud to share with you today. So we've been working on rules as code for several years now, but we've also seen really the rise in commercially available AI models, which got us started to wondering what's the crossover on AI and rules as code. And so our AI-powered rules as code research has focused on a question of, can generative AI be used to expedite the translation of policies into software code for implementation in public benefits, eligibility, and enrollment systems under a rules as code approach. You can find, and I should mention, you can find our entire report and the summary and takeaways on our website, and the link is here. And I will be presenting this research alongside many of our wonderful co-authors today. We started this work originally as part of the Policy to Code Prototyping Challenge, which we hosted last summer. That challenge included 12 teams from the US and Canada who were working on different use cases of benefits policy and AI. I encourage you to check out the website, which has 5-minute demo videos from every team, and you can hear more about the work and how that work has continued beyond the challenge. But next, I'm going to pass over to Jason, who will share more about the start of our research.
Thank you, Ariel. So as Ariel mentioned, we started our research as part of the prototyping challenge, and you can see our team here. Our team was called Hoyas Lexad Codex, which stands for Hoyas, that's Georgetown's mascot, and Lexad Codex is rules as code in Latin. As previously mentioned, we're a collaboration of the Beeck Center, the Massive Data Institute, as well as one more center at Georgetown, the Center for Security and Emerging Technology. I'm going to move on to the next slide, please. Thank you. So as part of our research, we ran experiments with SNAP and Medicaid policies across 7 states. And if you look at a report, you'll find more information on how we selected these states to account for a diversity both in their geography and their SNAP and Medicaid policies to make sure that we sort of ran the gambit in how those policies might differ in terms of their rules. We ran our experiments using the ChatGPT and Google Gemini chatbots, as well as the GPT-4o API, which is the API behind ChatGPT, in case you're unaware. Next slide, please. And we had 4 experiments as part of our work. Our first experiment looked at how well these large language models, which are the AI chatbots in the API, how well the models can answer general eligibility questions about SNAP and Medicaid policies. In our second experiment, we looked at how well the models answered those same questions, but when we provided the official policy documents to the models themselves. In the third experiment, we looked at how well the models produce programmable rules using a template with and without those policy documents. And finally, in the fourth experiment, we looked at how well an LLM could produce software code as a baseline for eligibility and enrollment systems. Next slide, please. So I'm going to dive into findings from our first experiment, which again was looking at how well the chatbots in the API could answer eligibility questions about Medicaid and SNAP. And we evaluated our responses, as you can see here in our methodology. We evaluated the responses based on current and state-specific applicability, completeness, and relevance. Next slide. And lo and behold, we actually found that there was no major difference in how well the three models we tested performed. We saw that the models performed reasonably well when we looked at how well the responses we got were state-specific and current and relevant, but we saw a big drop-off in how well those responses performed in terms of how complete they were. And we found that this was important because it's likely that the responses were missing information that would help determine whether an individual was eligible for SNAP or Medicaid. And the responses could also include irrelevant information, which might make that response less useful for assessing eligibility. Next slide. And something else we noticed was that Medicaid responses, as you can see here, were slightly higher than SNAP responses. And you can see here as well that this chart lays out the average scores for each of those three categories for the different policies we tested. Next slide. So the last thing I want to highlight is that all of our materials for our experiments are openly accessible. So for experiment 1, that includes the spreadsheet, that includes our prompts that we use to test, our scores for each of our responses, as well as comments. We also have a summary of the cumulative scores that inform the tables I was just showing you. And finally, we provide our rubric for how we assess the responses. And so you can dive in a bit more if you're interested in seeing exactly how we tested how well these LLMs could answer the different questions. So now I'm going to hand it to Alessandra, who's going to walk you through experiment 2.
Thank you, Jason. Yes, now I will talk about experiment 2, where we ask eligibility questions to the API guided by policy documents. So for our first step in our methodology, we had to extract and consolidate the policy documents, as many are not AA ready. We're gonna briefly touch on some observations on the next slide, but you're gonna find a table in that report that explores the strengths and weaknesses in a specific documents. For our second step, we generated prompts for a specific goals. And then we built a retrieval augmented generation environment, also known as RAG, which allowed us to use those specific documents with the GPT-4o API. We then evaluated the responses based on accuracy, completeness, relevance, giving points to each category between 1 and 5. Next slide, please. We looked at SNAP and Medicaid policy documents across 6 states each, but instead of using general rule summaries from state websites, we focus specifically on the official policy manuals. One of our biggest challenges, I think, was separate PDF documents. For example, in Georgia, at the time of our study, each section of the SNAP manual had to be downloaded as a separate PDF. So we had to take the extra step of manually extracting documents and merging everything. And then another issue was scanned documents, like in California. Some text in the PDFs could not be highlighted or searched, which makes it difficult for LLMs to actually process the text. We also had some observations in the difference in accessing manuals for the public across states. For example, some had super clean downloadable PDFs for HTML, like Michigan and Texas, while others had excellent online navigation, but were harder to download, like Pennsylvania or Alaska, where we had to web scrape from each subsection. Overall, I think this process gave us a deeper understanding of how accessibility and document structure can affect what LLMs can or can't do when analyzing benefit policies. Next slide, please. Yeah, so now focusing more specifically on the development of the prompts, we created 19 different prompt types for each state and each program. These prompts fall into categories such as eligibility criteria, eligibility scenarios, and plain language summaries. For example, as you can see on the screen, a prompt from the plain language summary category reads, please provide a plain language summary of the eligibility criteria for Medicaid in Pennsylvania found in the provided document. And from the eligibility scenarios category, a simple prompt might be, I am a single adult who cannot work due to a medical condition in Pennsylvania. Based on the provided document, what would determine if I am eligible for SNAP? Next slide, please. Yeah, so now focusing more on the results for experiment 2, in the visualization here in the center, text in the gray boxes shows the different questions topics that we included. And on the right and left sides, you'll see bars representing questions about Medicaid and SNAP. Each bar stands for one question and is tagged by score, blue for accuracy, green for completeness, and orange for relevance. Generally, we'll see accurate results. However, our scores dropped off significantly for completeness and relevance. If you're interested in knowing more about how your state performed, we invite you again to take a look at our full report. Next slide, please. And similarly to experiment 1, we found that while the response may be accurate, it is likely missing information that would help inform an action or decision about SNAP or Medicaid. So some of the common accuracy errors were misinterpretation of the data, eligibility criteria such as age, and also confusion between different groups' criteria. And there was also more focus on recent policies and ignoring older ones that still applied. And for common completeness errors, there was missing details for eligibility, focus on administration information like timelines and verification. And then for common relevance errors were off-topic answers or irrelevant elements, or elements that included unrelated things that confuse or dilute the main point. Next slide, please. As we mentioned, we invite you to take a look at our full report and also our openly accessible materials, which are going to include a spreadsheet prompts with scores and comments, the spreadsheet with all the cumulative scores, and the rubric. Thank you. I think now it's time for experiment 3.
Thank you, Alessandra. Yeah, so for experiment 3, we wanted to evaluate the abilities of LLMs to automate another essential component in our rules as code pipeline, where we specifically examined how well LLMs can generate programmable rules for different policies. So after a few initial iterations, we realized that like having a structured template of rules was like the key to getting reliable and consistent outputs from the LLMs. And it's also useful for replicating the results. And if you want to like audit our systems and get like consistent results throughout. So we designed this prototype template that you can see a snippet of here, where we clearly here like define each rule along with the data type it takes. And then the LLM's task just becomes filling out this template for each policy and state with accurate and up-to-date values. So for example, here, in the case of like the SNAP program, we have this rules template where we capture some eligibility criteria like income limits and work limits, etc. And then we explore 2 different strategies with this template, where in the first approach, we just used the standard GPT-4o model, and we prompted it to generate the values for each rule in the template without having access to external information. So that was sort of like our baseline model. And then in the second approach, we use the same prompt and the same model, but we add a RAG architecture, which basically gives the LLM access to a search tool that it can use to query and retrieve information from a database, which has relevant state policy documents. And then the retrieved content from the database is then incorporated and appended to the model's context, and then it helps it to guide its rule generation. Next slide, please. And then we evaluate the output of both approaches by comparing to like ground truth values that we extract ourselves from these policy documents. And we do this for SNAP in 3 states, Georgia, Pennsylvania, and Texas. And as you can see, the results in this table here, the plain prompting approach consistently like produced inaccurate results for all our categories. And these are like categories for different rules. So like you can see here, especially for rules that are different across different states, like income and asset limits, because like these are more numerical rules that have like different nature for each state. These are like were really hard to do without having access to external information from the specific policy documents. And then we can see here that the reg approach it produced much better results for the generated rules that like is more aligned with the actual rules, the actual values in the policy documents. But we note also that it still struggled with like instances when it cannot retrieve the information that it needs from the database, either because like the information does not exist or like it's not able to like come up with the relevant search query to get the target document. So we had 2 main takeaways from this. First, that we like having a structured template is very essential, very important for rules extraction, and also having like rules generation as a separate component in our pipeline can provide like a very strong, solid structure for our automated code generation pipeline. Can we go to the next slide? Yeah, and here we have our complete set of results. It's linked in our report. You can go like check what values were generated by like different settings and different models for different states. Next slide, please. Yeah, so moving on to experiment 4, where we were aiming here to examine how well can LLMs write code to determine benefits eligibility. So because this is like such a big task, we chose to focus on a small targeted task where we wanted to determine the worker registration eligibility for SNAP in the state of Georgia. And in this experiment here, like for all the settings that we tried, we provide the LLM with an excerpt of the relevant policy documentation, and we prompt it to generate code in different settings that we will go over in the methodology. And then we evaluate the output of the LLM, like the code that it generates, and like whether this code works and whether it works like in the way that we expect it to. Next slide, please. Yeah, so here we use 3 different strategies to analyze the LLM code generation performance. So the first is our baseline model, and it involves prompting the LLM GPT-4o with the relevant policy excerpt that is like relevant to our task here, and we prompt it to write code that takes input from the user, and it should output the user's worker registration status, and that is like whether they're required to register for employment to qualify for the benefit. And then we review the output of this approach. And because this is just like a baseline, we noticed several issues with it, and we use like all these issues to like develop a detailed set of instructions that aims at like correcting some of these problems and try to like to steer the model closer to getting the output that we expect. And then we use these instructions in the second approach, and we append these instructions to the prompt along with the same policy excerpt. And then we ask the LLM to generate the same code. And then for the third approach, we try something a little different, where we create like a structured pipeline for the code generation process. So instead of just like having the LLM do it in a single shot, we split it up into 3 different stages. The first is the policy summarization, followed by pseudocode generation, and then the final code is generated. And each step's output here is the input for the next step. And our goal here was just like to break down the task and assess the model's performance at each step in the process. So like, for example, in the summarization step, we evaluated the model's ability to extract and restructure the key information it can from the original policy document. And then in the pseudocode step, we try to get at the logical reasoning capability of the model and how well it could turn the information it extracted from the policy document into a set of decision-making steps and logical flow. And then finally, the code generation step, it gets at how well or how accurate it can translate the pseudocode generated from the previous step into executable code that like performs the task, and it's like while keeping the policy context in mind, like, and keeping in context what it's trying to do, like to model the task that we have. Can we go to the next slide? And then, yeah, we analyzed the output from each of these three approaches, and we summarized the results using some key qualitative metrics that you can see in the table here. So at a very high level, we noted that the second approach, the one where we use the detailed prompt, is the one that performed the best. And the baseline approach, as expected, had the weakest performance and the worst code quality, but it still served like an important rule for as like a useful and informative step for us to prompt engineer for the second approach. And then, interestingly, in the third approach, where we had like the multi-step pipeline, we did see some improvement in performance across like different at each stage, but like a major challenge was in how error was accumulated and propagated from one step to the next. So, for example, if the model makes a mistake in the pseudocode step, then this mistake will be carried over to the code generation step. But we also know that this kind of modular design allows us to debug and correct errors at each step, which is kind of like a little harder to do in a single shot pipeline. Yeah, and as with the previous experiments, you can find all our materials, the code that the LLMs generated for different settings, and the prompts that we used to get these codes linked in our report, as long as with our comments for like the annotations for the code and how well the LLM did. And I'll hand it back to Ariel.
Thank you all for sharing the details in our experiments. I'm here to share some high-level takeaways from all of this work. So one, kind of answering our original research question is, yes, LLMs can help support our rules as code pipeline, but with some words of caution. So one, humans really still have to be in the loop in these processes, and really any benefits related use case, that accuracy and equity considerations must outweigh the efficiency in these high stakes benefit systems. We also found that we really need to use the authoritative sources, and it's possible to improve the performance of the benefits related responses by pointing LLMs to authoritative sources like the policy manuals. But as we showed you in experiment 2, state governments can really make it easier for LLMs to use these policies by making them more digitally accessible. And we're really happy to talk with anybody who's trying to work on this for some pointers on how that might help you out, because AI is here and the models are definitely looking for this source information. Also, when we just ask LLMs to write policy code directly, it leads to pretty poor code. And so this is really another moment where humans have to be in the loop, and there is this really curation required. So when we're doing code generation, it can be improved by using an LLM with retrieval augmented generation to generate the machine readable policy rules, but it requires still that manually curated template. And so still pretty big human components involved in that. I also wanted to share some impacts on people. And so I think it's one thing if we're using LLMs to generate code for these systems, but part of why we started in experiment 1, just directly asking some of the chatbots without pointing them to the policy manuals, is we were really curious to see what kind of information the public seeking information about benefits might be getting from these systems today. And as you saw, we had pretty mixed results in experiment 1, which really shows that these are having direct impact on people who are seeking or receiving benefits. It's risking a lot of incorrect information when they ask generative AI models questions, but also things like Google search has Gemini integrated into it now. So you're getting an AI response very early on the search page very frequently. And so people are probably getting some information that's not correct or complete today. And the other thing is about these models and the responses is that when they provide incorrect information, they often do so in a very confident tone, which is very likely to mislead those who may not have the subject matter expertise on the particular policies or just seeking assistance. So it's here and now, and there's some ways that we can work together to address it, and really excited to open that into conversation. We're also really interested in future experimentation in this space. We're one of many doing open research on it, but we would love to see a lot more. And so some of the kind of low-hanging fruit of things we could work on are things like repeating these methodologies that we presented today in our experiments for other states, other programs or policies, and on all other LLMs as well. We could also use different programming languages for the code outputs. We would also love to really see more pairing between policy experts and software engineers to be able to program and evaluate hand in hand. We have a lot of generalized knowledge, but would love to be able to work more closely with those with the really deep policy expertise. Also really possible to explore specific program or policy LLMs, the models that are curated towards those specific programs. There's a great question in the chat about this, as well as compare rules against existing systems. So we are creating rules based on our own reference of policy manuals. We've not had access to actual government system code. We would love to do that comparison. And similarly, a lot of states are working on extracting code from legacy systems. This is definitely something that LLMs have a likelihood of being able to assist with. And some of the techniques that we used are likely to be able to be applied to help assist that process as well. And then I think a big question that remains in this space is comparing the code writing efforts of humans writing code versus the policy analysis efforts, and are we actually saving time when we use LLMs in these processes as a tool to help us write code faster? There still has to be a lot of review, and so does it actually save us time or not? And then we're also very interested in the idea of designing a prototype toolkit to test different rules and code generation prompts around specific programs such as SNAP. So happy to talk about any of those ideas further, but to kind of last plug on our report, if you haven't been on the Digital Government Hub yet and taken a look, there's the full report, which is a long read with a lot of details in it. We also created a summary and key takeaways version, which is a little more accessible. And then as we've shared, we've also opened up our materials, including the rubrics, prompts, results, scores, and code samples, which are there for you to see more detail in how we ran the experiments and the actual results from them, but also openly available for anyone who would like to reuse them for their own work and experimentation. We've already had a member of our community of practice has actually taken some of our prompts and run them in a different model already. So it's been really exciting to see the open source stuff taking off a bit as well.